welcome to Megha's tutorial. In today's class we are going to study the circles of class 10th. Okay, so in that the first one problem is we have given here, prove that in two concentric circles the chord of larger circle which touches the smaller circle is bisected at the point of contact. So we are given two circles here. First circle is C1, another circle is C2 here. This is the circle C2, this is the circle C1. Okay, these are having the center O and the chord AB of the larger circle C1. It touches the smaller circle C2 at point P. We need to prove here that AP is equal to BP. AP is equal to BP. Then let us join this OP. We will draw a dotted line here by joining OP. Then AB is a tangent to circle C2 at point P. Then OP is the radius. Therefore, by the theorem 10.1, we can write OP is perpendicular to AB. This is by theorem 10.1. In your textbook you are given the theorem 10.1. It states that the tangent to any point of a circle is perpendicular to its radius, to the point of contact. Now here AB is a chord of circle C1 and OP is perpendicular to AB. Therefore, OP is the bisector of the chord AB, we can say. OP is the bisector of chord AB. Then it is the perpendicular from the center which bisects the chord. Therefore, we can say that AP is equal to BP. Okay. So this is the solution for the first problem. The second problem is two tangents TP and TQ are drawn to the circle with center O from the external point T. We have to prove that angle PTQ is equal to 2 times the angle OPQ. Okay, so here we are given a circle. In the question we are given the circle. It is having the center O and T is the external point. It is having two tangents TP and TQ to this circle where P and Q are the points of contact. We need to prove that angle PTQ is equal to 2 times the angle of OPQ. Let us consider angle PTQ is equal to theta. Let us consider angle PTQ is equal to theta. Then by the theorem 10.2 in your textbook, what is the theorem 10.2? Theorem 10.2, it states that the lengths of the tangents drawn to a circle from this external point are equal. Okay, these tangents will be equal. That is the theorem 10.2. Using that theorem 10.2, we can write TP is equal to TQ. TP is equal to TQ. Okay, this is according to the theorem 10.2. The tangents will be equal when they are drawn from the external point to a given circle. Therefore, TPQ is an isosceles triangle. Therefore, we can write angle TPQ is equal to angle TQP is equal to half of 180 minus theta. Now you divide this to the terms in the bracket. You will get this as 90 degree minus half of theta. 90 degree minus half of theta. Also from the theorem 1.1, we can write angle OPT is equal to 90 degree. This is from the theorem 10.1. So from these two, that is from angle OPQ, it is taken as angle OPQ is taken as angle OPT angle TPQ. Okay, the sum of these two is taken as the value of angle OPQ. Angle OPQ is taken as angle OPT minus angle TPQ. This is equal to 90 degree. From the diagram, the value of OPT is equal to 90 degree, right? Minus, already we know the angle value of angle TPQ, that is something but 90 degree minus half of theta. Now we can write this one as 90 minus 90 plus, minus into minus plus, plus half of theta. So these two gets cancelled, remaining is half of theta. That is angle OPQ is equal to half of theta. But already we have considered the theta value as half of this theta value as angle PTQ is equal to OPQ. Or we can write this one as angle PTQ is equal to 2 into angle OPQ, which is the required solution here. We need to find that angle PTQ is equal to 2 into angle OPQ. Okay. PQ is a chord of length 8 cm. You are given in the circle of radius 5 cm. The tangents are at point P and Q. They intersect at point T. You have to find the length TP here. Let us join OT. Let it intersect PQ at the point R. Then triangle TPQ. It is an isosceles and TO is the angle bisector of the triangle PTQ. So OT is perpendicular to PQ and therefore this OT bisects the PQ, which gives the value of PR is equal to RQ is equal to 4 cm. The whole length is equal to 8 cm. So we can say PR is equal to RQ is equal to 4 cm and also OR is equal to root of OP square minus PR square. OP square minus PR square, that is equal to, from this diagram OP is equal to 5 cm, that is 5 square minus PR is 4 cm, that is equal to root of, you will get 25 minus 9. 25 minus 16, that is equal to 9, or it is equal to 3 cm. Okay, 3 cm. Now here angle TPR, this angle TPR plus angle RPO, it is equal to 90 degree. Therefore angle RPO is equal to angle PTR, we can say. Therefore the right triangle TRP is similar to the triangle RPO. This is by the angle similarity, which gives TP divided by PO is equal to RP divided by RO. RP divided by RO, that is the value of TP we have to find here. So keep it as it is. TP divided by PO. The value of PO is 5 cm. 5 is equal to RP. RP is 4 cm divided by RO. RO, the value of RO is already found here, that is 3 cm. So we can write TP is equal to, which implies that TP is equal to 5 4s are 20. 20 divided by 3 cm. This is the value of TP, that is the length TP. This is the third example. TP is equal to 20 divided by 3 cm.